Okay, everybody, in this video I want to talk about a couple of rules that come with disjunctions. Let me explicitly state by saying that I know I've already established that there are two kinds of disjunctions. There's the inclusive kind and there's the exclusive kind. I'll say when dealing with disjunctions, you'll notice here I have two rules. I call these constructive dilemma or out. Addition, not to be confused with adjunction. Okay, we typically think, oh, I'm doing an and in, I'm adding these things together. No, you're not. Or in will be what we call addition or adding. With these, you can only get, all right, or whatever your conclusion is, or your derivation, or whatever you deduce using these rules I'm about to introduce, you can only get an inclusive disjunction out of it. There's no such thing as XOR in, that doesn't exist. Neither is there a thing as XOR out. Neither one of those things exists. So if you're going to use either one of these, and again, I'm going to explain in a moment what they are and how to use them, you're never going to get an XOR as a result. You're never going to get an exclusive disjunction as a result. There are ways to get an exclusive disjunction out of a problem. Again, like if you were doing an arrow out or something like that. But when you employ these, that conclusion itself, at least as the main operator, cannot be an exclusive disjunction. Now here's how these work. Addition, this is going to seem, this is one of the most bizarre rules in formal logic. It seems like it shouldn't work, but because of the nature of disjunctions, for a disjunction to be true, only one part of it has to be true. So if we establish something, like for example, I'm Professor Burris, or I am the king of the universe, is a true statement because one part of it's true. And for an inclusive disjunction, all you need is at least one part to be true. For an exclusive disjunction, you need only one part to be true. But that's the nature of disjunction. As long as one part is true, you're good. And if you take anything to be established, let's say we've got A here sitting as an assumption. We can add anything onto that. By add, I mean do this or in. We can stick any inclusive disjunction on top of this that we want. Where did it come from? Nowhere, but the thing to keep in mind is what we're adding it on to. We have to have something already established to add on to. Okay, so what can I get from A? I could get A or B. How? Or in. On to line 1. So when we use addition, you can stick an inclusive or with anything on to something that you've already established as a given, or a derivation that you've made. So now, for example, I could stick onto this, A or B, or C, or in on line 2. Because as long as you've got something established as true, you can add anything onto it that you want. This is what you do if you've ever done this in conversation where you're like, well, hey, we could go to the movies, we could go shopping, and you just leave that or hanging out there. You're telling whoever it is you're talking to, well, you can add on your own thing. Maybe we won't do it, but I'm just throwing it out there. That's what we do with disjunctions. Now, we can also add on, let's say technically, dextrally or sinistrally, which is to say, a moment ago I had A or B. I could add on to the right, or I could add on to the left. I could say B or A. What did I add it on to? Oh, I did it or in there, I added on, still to line 1, you can add on to either side. Now, you can't just do this out of nowhere. If I had no assumptions, I could not just say or B. Neither could I say A or B. I'm just going to throw it out there, unless you were doing a translation, of course. I have an already existing inclusive disjunction. But so, if you've got any established premise, okay, it could be Z arrow Q. Let's take that as an assumption. I could say, let's assume that Z arrow Q is true. I could add anything onto it that I want, to the left or right. Z or Q, only one at a time though. Z or Q or R, or in to line 1. Now to be clear, you cannot ever do this. You got an assumption, you go, okay, you said we could do or in, I'll say A XOR B, or in line 1. Nope, that's not a thing. You can never, if you've taken A to be true, and then you say, or this but not both, there's no way that could work and still be true. Because B might be true. You can't just add it onto it and say, well, it's got to be one or the other but not both at that point. This is a fairly common fallacious way of reasoning. It's actually affirming a disjunct. It's a formal fallacy where you add on an XOR. You can never ever do that. It's not valid. So I've said a lot about this addition one. It's going to seem very confusing, but I'll just say for our purposes, you can add on anything to anything with an or in. And the number that you cite in the reasoning on the right-hand column is what you added, whatever it is, on to. Like I put this marker here, less permanent, on to the board. It was added to the board, so you could say I added on the marker to the board. So that's kind of the way that or in works. You add something on to something that is more fixed and established. Now once you do that, you can't just take it away. It's not like conjunctions where you can just break them apart whenever you want. We'll get to or out in a moment. It doesn't mean that you've got an or statement. Hey, I can just snap in half like I do with conjunctions. It doesn't work the same way, and that's what I'll address in the next video.